So in this section in our text, they talk about normal lines, and the last section we learned about tangent lines and coming up with the slope of a tangent line or the equation of tangent line to a curve at a point. So this is a pretty similar idea. A normal line to a curve is a line that's perpendicular to the tangent line at that point of contact. And from geometry, we know that perpendicular lines have opposite reciprocal slopes. So if you know the slope of the tangent line, then you'll know the slope of the normal line will be the opposite reciprocal. And since the derivative gives us the slope of the tangent line, f prime of a, let's say, at the point x equal a, then the slope of your normal line will be negative 1 over f prime of a. So let's just look at an example to put this into context. What if I asked you to find the equation of the normal line to y equal ln of 2x at x equal 3? Well, to find the equation of a line, we need two things. We need a slope and we need a point. And so the first thing we're going to need to do is, well, we can get the point. That's easy enough. It's 3 comma, and then if I plug 3 in, I'm going to get the natural log of 2 times 3, which is 6. So 3 comma natural log of 6 is our point, and now we need to figure out our slope. And so if we take the derivative, that'll be the slope of the tangent line. So what's y prime for this one? Well, the derivative of the natural log of something is 1 over something. And then the chain rule times the derivative of 2x, which is 2. And so the 2's cancel, and we get 1 over x. So at x equals 3, the slope of the tangent line is 1/3. That means the slope of our normal line is going to be negative 3 over 1, or negative 3. And therefore, we can get the equation of our normal line now that we have a point and a slope, and I'll just use point-slope form. So we have y minus the natural log of 6 equals negative 3 times the quantity x minus 3. And it's easy enough. So it's just one more step than finding the equation of the tangent line. We just have to flip the derivative and take the opposite of it. One thing I wanted to point out, when you were taking the derivative of y prime, you can look at this using properties of logs and say, oh, the product property says that's the natural log of 2 plus the natural log of x. And so when I take the derivative, the natural log of 2 is just a constant, so its derivative is 0. And then the natural log of x, the derivative is 1 over x. And that's why those 2's cancel, and that happens in any case where it's the natural log of a constant times x. All right, so a few problems to work through. In section 13b starts on page 320.